Welcome to the next tutorial. Here I will be discussing the solutions to the problems. Okay, first let us start with the problem number 1. See figure 1.1. So let me pull out figure 1.1. Okay, this is the figure 1.1. The resistances are connected in series as shown. Calculate 1. The current flowing through the 5 ohm resistance, current through R, the value of resistance R, and the value of V. What I did is I separately drawn this diagram in another scratch pad so that it becomes easier for me to solve the problem. Okay, first of all I have to find out what is the current flowing through the 5 ohm resistance. Current through 5 ohm resistance. Now the potential difference across this 5 ohm resistance is 10 volt. And the resistance is 5 ohm. From Ohm's law we can say that V equal to I multiplied by R. Now potential difference V is 10, therefore I equal to V upon R, which is 10 by 5. 10 by 5 comes to 2 ampere. That means current flowing through the 5 ohm resistance is 2 ampere. Okay. What is the current flowing through R? Now see, R, the resistance R and 5 ohm, they are in series. That means same amount of current will flow through R also. That means current flowing through R will be 2 ampere. Current through R is also 2 ampere as it is in series. When they are in series, same current will flow through all the resistances. Same amount of current will flow. What is the value of R? Now here it is interesting. Now I got the current flow through R. Current flowing through R is 2 ampere. We have to find the value of R. Now V equal to I into R. V is 6 volt. Potential difference across R is 6 volt. Current is 2 ampere. Therefore R equal to 6 upon 2, which is 3 ohms. So value of R is 3 ohms. What is the value of V? Total V means voltage of the battery. Now voltage of the battery is distributed amongst two resistances. So if we add 10 with 6, which is becomes 16 volt, that will be the voltage of the battery. So V equal to 10 plus 6, because this voltage will be distributed amongst these two resistance. So if we add the two voltages, it will be like the voltage of the battery. Next question, see figure 1.2. Let me pull figure 1.2 here. Here we can see three resistances in series and parallel both. Okay, calculate the total resistance and what will be the reading of the ammeter. That means what will be the current flow. I have drawn this figure separately in another scratch pad so that it becomes easier for me to solve the problems. Now first of all I have to calculate the total resistance. Now see, in the below there are two resistances, 3 and 2 ohm. They are in series. So equivalent of these two resistance will be 3 plus 2, which is 5 ohm. So 3 plus 2 ohm in series is same as 5 ohm. So now I can say that this circuit has two 5 ohm resistances, because these two becomes 5 ohm and there is another 5 ohm at the top. So two 5 ohm resistances are in parallel. So 5 ohm and another 5 ohm. Now these two 5 ohms are in parallel. So this is the sign of parallel, two vertical lines in parallel. So So these two 5 ohm resistances, when they are in parallel, their equivalent resistance can be found using the formula 1 by R equal to 1 by 5 plus 1 by 5, which is 2 by 5. Therefore R equal to 5 upon 2. Now 5 upon 2 is 2.5. So the total resistance of the circuit will be 2.5 ohm. So total resistance is 2.5 ohm. Now what will be the reading of the ammeter? Reading of the ammeter means what is the current flow. What is the reading of the ammeter? That is, if the current flow is I, okay, to find the current flow, we use the formula V equal to I into R. Here V is 4 volt, I is unknown, and total resistance is 2.5. Therefore I equal to 4 by 2.5. Now 4 by 2.5 is coming to equal to 1.6 volt. So this is coming to 1.6 ampere. So current flowing through the circuit is 1.6 ampere.